In the next few minutes, you'll learn how sampling methods shape results, why easy samples can be misleading, and how to spot the SAT's most common traps. We'll keep it simple, visual, and test-focused, so you can answer faster with confidence. When you work with data, the biggest mistakes often happen before you do any math. They happen when the data comes from a biased sample or a sample that doesn't represent the population. On the SAT, this shows up all the time. A result might look convincing, but if the sample was collected in a flawed way, the conclusion can be wrong. And even a large sample can still be misleading if certain groups are overrepresented or others are missing. In this lesson, you'll learn how to identify random sampling, recognize convenience sampling traps, check whether proportions match the population, and avoid conclusions that go beyond what the data actually supports. The goal is simple: make better inferences, faster. Let's start with the most important idea in sampling: random sampling. In random sampling, every member of the population has an equal chance of being selected. This phrase, equal chance, is the key signal you should always look for on the SAT. Look at the diagram on the right. From the same population, two different random samples were drawn. Sample A and Sample B. Even though both used proper random selection, they ended up looking quite different from each other. This illustrates a crucial point. Equal chance does not mean identical results. Different random samples can look different, even when the method is completely correct. This natural variation between samples is called sample-to-sample variation, and it is completely normal. Random sampling helps protect against selection bias because no group is intentionally favored. However, random does not mean perfect. A random sample is more reliable on average, but conclusions should still be made carefully. When you see a question about sampling, always ask yourself, does everyone truly have an equal chance to be chosen? If yes, the sample is likely random. If not, bias may be present. Now let's look at a sampling method that introduces bias: convenience sampling. Convenience sampling means that people are selected based on ease or availability. In other words, the sample is made up of individuals who are easy to reach, rather than individuals chosen through a fair random process. Take a look at the diagram. The population at the top includes many different groups, represented by circles. Notice the pink box in the middle highlighting the easy-to-reach group. The convenience sample, shown in red at the bottom, is drawn mainly from this one group. These individuals were chosen not because they represent the population, but simply because they were nearby or accessible. This creates selection bias. As the diagram shows, the same group dominates the sample, while other groups are completely missing. Even if the sample size looks reasonable, the results can still be misleading because they only reflect one segment of the population. This leads to an important SAT principle: convenient does not mean representative. A sample can be quick and easy to collect, but that does not make its conclusions reliable. When you see a sampling question on the SAT, always ask yourself, were people selected because they were easy to reach, or because everyone had an equal chance to be chosen? If selection is based on convenience, bias is almost certainly present. Now let's move to another key idea in sampling: representativeness. A sample is representative if it accurately reflects the population. This means that important groups in the population appear in the sample in similar proportions. Take a look at the diagram. At the top, you see the population, made up of two groups shown in different shades of blue, a larger Group A and a smaller Group B. These proportions show what the population actually looks like. Now compare the two samples below. In the representative sample on the left, the proportions closely match the population. The blue bars maintain the same relative sizes. Even though the sample is smaller, it still accurately reflects the population's composition. In contrast, look at the biased sample on the right. Notice how the larger group, now shown in red, has become disproportionately large, while the smaller group has shrunk even further. One group is overrepresented, while the other is underrepresented. Even if this sample were very large, it would still give a distorted picture of the population because the proportions don't match. This leads to a crucial SAT principle: big does not mean representative. As the caption emphasizes, size alone does not ensure representativeness. What matters most is whether the proportions match the population. When you see a sampling question on the SAT, always examine the proportions. Are the key groups represented in the sample the way they exist in the population, or is one group overrepresented? If the proportions are distorted, the sample is not representative, no matter how large it is. Now let's look at an important distinction: association versus causation. Take a look at the pattern in this scatter plot. The data points follow a clear upward trend, with a line of best fit showing a strong positive association. When one variable increases, the other tends to increase as well. This is what we call an association or correlation. The data shows that these two variables move together. However, and this is crucial, notice the red X at the bottom of the slide. As the caption states, a trend does not prove cause. Just because two variables are associated does not mean that one causes the other to change. The relationship you see might be due to a third variable affecting both, or it could be coincidental. This is one of the most important principles in statistics, often stated as, correlation does not imply causation. On the SAT, you may see data showing a clear association, but the question will ask whether a causal relationship has been proven. The answer is usually no, not without additional evidence. When you encounter a question showing an association or trend, always ask yourself, does this data prove that one variable causes changes in the other, or does it simply show that they tend to move together? Let's pause and summarize what we've learned so far about sampling and inference. As this slide emphasizes, good data does not start with fancy graphs or calculations. It starts with good sampling. Let me walk through the 5 key takeaways on the left. First, random sampling means every member of the population has an equal chance to be selected. This reduces selection bias, but it does not guarantee identical results every time. Second, convenience sampling selects people simply because they are easy to reach. This often creates bias, even if the sample size looks large. Third, representativeness depends on proportions, not size. A sample can be big and still biased if key groups are overrepresented or missing. Big does not mean representative. Fourth, correlation does not equal causation. A trend may look convincing, but it does not prove that one variable causes the other. And fifth, poor samples lead to bad inference, conclusions that seem reasonable, but are not reliable. Now, how do you apply this on the SAT? The right side of the slide shows 3 questions you should always ask yourself. Question 1. Did everyone have an equal chance? If not, it's probably not random sampling. Question 2. Do the proportions match the population? If not, the sample is not representative, even if it's large. Question 3. Is this correlation or causation? If the data only shows association, you cannot claim cause and effect without more evidence. Keep these 3 questions in mind, because in the practice problems, we'll use them to justify every answer. Take a look at how the sample was selected. Only students eating lunch in the cafeteria at noon were surveyed. That means not everyone had an equal chance to be chosen. Students who eat later, skip lunch, or eat elsewhere were excluded. Because selection was based on convenience, this sample is biased. Let's walk through the answer together. Yes, this sample is biased. Let me explain why. The key issue is how the students were selected. The principal surveyed students eating lunch in the cafeteria at noon. These students were chosen simply because they were easy to reach at that time. As a result, not all students had an equal chance to be chosen. Students who eat lunch at different times, bring food from home, skip lunch, or eat in other locations were completely excluded from the survey. Look at the diagram on the right. At the top is the full population of all students. The pink box highlights the easy-to-reach group, students in the cafeteria at noon. Below that, the convenience sample, shown in red, comes almost entirely from this one group. Other groups in the population are missing. This is why the sample is biased. Selection was based on convenience, not equal opportunity. Here's the key principle. Convenience sampling often leads to bias because people are chosen based on availability, not because everyone had an equal chance. The results may not represent the full population. On the SAT, always check the sampling method. If you see convenient, available, or easy to reach, be alert for potential bias. Let's look at this intermediate practice question. A school randomly selects 200 students from a list of all enrolled students to estimate preferences for online homework. Even though the result says 70% prefer online homework, don't focus on the number. Instead, think carefully about how the students were selected. The correct answer is no, this sample is not likely to be biased. The most important detail is how the students were selected. The school randomly chose 200 students from a list of all enrolled students. This means that every student in the population had an equal chance to be selected, regardless of their schedule, location, or preferences. Because the selection was random and not based on convenience, the sample avoids the main source of bias we saw in the beginner example. Even if the results seem unexpected or surprising, that doesn't mean the sample is biased. What matters is the method, and this method is sound. Now look at the diagram on the right. At the top, you see the full population of all enrolled students. Below it, the random sample is drawn from the entire group. Notice the dotted lines connecting the population to the sample. This represents equal opportunity. No single subgroup is targeted or favored based on ease of access. This highlights an important principle. Random sampling does not guarantee a perfect result, but it does give every individual an equal opportunity to be included. That is what makes the sample generally unbiased. The micro tip at the bottom reinforces this. A random sample from the entire population is generally unbiased, even if the results are surprising. Surprising outcomes don't indicate bias, they're just part of natural variation. On the SAT, always separate the sampling method from the outcome. If the sample is random and drawn from the full population, the method is sound, even if the result seems unexpected. Now let's move on to an advanced practice problem. This question combines sampling, bias, and inference, so you'll need to think carefully. You have 2 minutes to think about this problem. A school district reports that students who voluntarily signed up for a new online learning platform showed higher test scores. Before jumping to conclusions, ask yourself, how were the students selected, and what does the data actually prove? Let's go through the correct answer together. The correct answer is B. The students were not randomly selected, so the sample may not be representative. The key issue here is how the data was collected. Look at the diagram on the right. At the top, you see the full population, all students in the district. Notice the label, voluntary sign up. The students in this study were not chosen at random. Instead, they voluntarily signed up to use the new online learning platform. This creates what we call self-selection bias. Students who choose to participate on their own may be more motivated, more engaged, or already performing at a higher level than the average student. Follow the arrows down in the diagram. The sample, shown in blue, consists only of these voluntary participants. Because of this, not every student in the district had an equal chance to be included. As a result, the sample may not represent the full student population. Now look at the bottom of the diagram. The observed result shows higher test scores among participants. At first glance, this might seem to prove that the platform works. But notice the red X with the label, causation jump. This marks a critical error in reasoning. The data shows an association between using the platform and higher scores, but it does not prove causation. We cannot conclude that the platform caused the score improvement. Other factors, such as motivation, study habits, or prior achievement, could explain the difference. This leads to the key idea at the bottom of the slide. Correlation does not imply causation, especially when the sample is not representative. On the SAT, always separate the method from the outcome. Even impressive results do not justify a causal conclusion if the data comes from a biased or self-selected sample. This is exactly the trap this question is testing. Let's wrap up the key ideas from this lesson on sampling, bias, and inference. First, good data always starts with good sampling. Before analyzing results, ask how the data was collected. Second, random sampling means everyone has an equal chance to be selected, which helps reduce bias. Third, convenience sampling often leads to bias because people are chosen based on availability, not equal opportunity. Fourth, representativeness depends on proportions, not just sample size. A sample must reflect the population structure. Fifth, large samples can still be biased. Size alone doesn't guarantee accuracy. Sixth, correlation does not imply causation. Association doesn't prove that one variable caused the other. Seventh, poor samples lead to bad inference, even when analysis appears sound. And finally, the most critical principle for the SAT: always examine the method before trusting the result. Separate how data was collected from what it appears to show. This habit will help you avoid common traps on the test.